Hello and welcome to Education at SSBJ online video tutorials. We shall take up some important concepts of class 9th CBSE chapter motion. Let us start with a question. It reads, a man travels a distance of 1.5 meters towards east and then 2.02 meters towards south and finally 4.5 meters towards east. What is the total distance traveled? Okay, and what is the resultant displacement? Right. So we'll take up this question and start discussing few concepts related to this question of chapter motion. So please remember, this is for class 9th CBSE. After all, what is motion? What is the definition of motion? When do we say that a body is in motion? An object, if it moves, let's say an object which was here at position A, and if that object changes its position to B, so there is a change in position. Okay, and if there is a continuous change in position, with respect to time, so these terms are very important. So let me repeat, if a body changes its position continuously with respect to time, means it was here when the object was here, it was 1 second, then it became 2 seconds when the object was here, and somewhere 4 seconds when the object reaches here and continued, and in that case a body is said to be in motion. The definition is, a body is said to be in motion or moving when its position changes continuously with respect to time. So when you write this as a definition, so you have to write two terms very important, which are change in position with respect to time and continuously. Right? Now with this we'll move to the next concept now, to understand what do you mean by distance traveled as well as displacement, because these two are required to solve those questions which we have taken in the beginning of this video. Let us take an object at position A. Now when you take an object as position A, let us have a clear understanding of the directions on the map or on paper. So usually on map you must have studied in geography that the north is towards upward, and then this is east, south and west. So keep that in your mind. Okay, so our question demands understanding of direction on paper, right? And suppose if position of this changes, now let's say it has gone to position B, and then in which direction it has traveled? It has traveled towards east, right? It has gone towards east, and then suppose from this position it has taken turn exactly 90 degree and went towards north. So it goes towards north and reaches another position here, and that position we'll call it as C. So which was the initial position? A is the initial position, and then C will be the final position. It has moved from A to B and B to C. Let's draw that path. A to B it has moved, and then it has moved to B to C. Let us consider that suppose if it moves from A to B for some distance, let's say 4 meter distance, and then from here it has moved, let's say some 3 meter distance. Now we will take this example to understand what is the meaning of distance traveled as well as displacement. right? So distance traveled is the actual path traced by the body. And what is the actual path? That is from A to B, 4 meter, right? Then from B to C, 3 meter. So that becomes 7 meter. So 4 meter plus 3 meter, which will give you 7 meter, which is the actual distance, actual path covered by the body. And what is the definition of distance traveled? The distance traveled by the body is the actual path covered or actual length of the path covered by the body, irrespective of its direction in which the body travels. So please remember that as far as distance is concerned, we are not bothered about the direction. In this example, once the direction is changed here. Okay, so irrespective of the direction, the total distance covered is 4 plus 3, that is 7 meter, right? So please remember this. We are not considering any direction as far as distance is concerned. Then what is displacement then? Okay, now what is the definition of displacement? Please listen to this. Definition of distance is the shortest distance. Okay, shortest distance between initial position and final position. Now what is initial position here? This is the initial position, this is the final position, and the shortest distance is very simple. This is the dotted distance which is shown here in front of you is the displacement. So this AC can be a displacement. Now how will you find the distance, that is the length of this displacement? So use Pythagoras theorem. So since this is a right angle triangle, so AC square is equal to AB square. So AB square plus, AB square is here and BC square, right? So therefore AC square is equal to AB square is 4 square. Okay, I'll take it in bracket, and 3 square, which will be equal to 16 plus 9, and that is 25. But AC square is 25, so AC is equal to square root of 25, which is equal to plus or minus 5, but we have to consider this as a positive 5 meter, right? So therefore the displacement is 5 meter, right? So please remember here, see, in this example we have a distance traveled 7 meter. Distance traveled is greater than the displacement. Why? Because the displacement is the shortest distance between initial and the final position. Okay, then can this distance traveled be equal to displacement? And in what case it can be equal to displacement? And is there any possibility for a displacement greater than the distance? We shall discuss in future examples here. Let us take one example here, and let's say that body is shifted. I think it is changed in its position from position A to position B, right? And that position we are going to trace it, and that is almost equal to 4 meter. In this case, what is the distance? Distance is the actual distance traveled. And what will be the actual distance traveled? It's a straight line distance, so it is very easy already, which is given here 4 meters. So distance traveled obviously will become 4 meter. And what about the displacement? Displacement is the shortest distance between the initial position and the final position. And what will be the shortest distance? That itself also will be 4 meter. So this is an example where the distance traveled will be equal to, both will be equal to displacement. Suppose if the object B comes back in its initial position, right? So the object has gone here and traveled for 4 meter, then he has come back, traveled another 4 meter, distance is increased, 4 meter plus 4 meter, which will be equal to 8 meter. And what is the shortest distance between initial position and where was the initial position? A. Where is the final position? A, because it has gone and come back. So what is the distance between them? Is 0. Therefore, look at this. If an object comes back to its initial position, then the displacement becomes 0. Right? And again, let me tell you, we are not considering any direction as far as distance traveled is concerned, because it is moving in east direction and it comes back towards west direction. While going, it is here, and this way it comes back. Okay, let's go for one more example here. Let us take an object which is at position A, right? And then it takes one circle completely. Okay, and then it moves along the circle, that is on a circular path, exactly on a circular path, and it comes back to its original position. Now, how will you find out the distance, and what do you mean by distance? The actual path covered. And what is the actual path covered? Actual path covered will be, you have to measure the edges of this circle, and what do you call that? Circumference. And how will you give that circumference? Using formula. 2 pi r is a formula for circumference, that is 2 into 22 by 7 into r, whatever is the radius. Let's have a radius also here. Let's take an example that the radius is 7 meter, so that our example becomes more simple for calculation. So we shall now find out what is the distance traveled. So 2 into 22 by 7 into 7 meters. Right, so 7 goes, it becomes 44 meters, right? So distance traveled is 44 meter. What about a displacement? A displacement is 0. Why 0? Because the object has started from position A and then it comes to position A back. So the shortest distance between these two initial and final position will be 0. Now we'll conclude this about distance and displacement. What will be the definition of distance and displacement? The bottom which is given here is the definition of distance covered. And what is distance covered? Look at the terms. Actual length covered. Okay. And what's the displacement? The shortest distance, shortest and straight distance. And why that straight distance? This has some direction. Okay, for example, suppose if the body is at A and it moves all around and comes back here to B. Now when you are finding the length of the distance covered, you have to go all over this path. So direction is not important for you, whereas as far as displacement is concerned, you have to draw a straight line from A to B, which is in particular direction, this direction, right? So always displacement has direction. Displacement has direction. Now let me tell you one more important term which is used, that is magnitude. And what do you mean by magnitude? So magnitude means, for example, suppose if I express distance, okay, let's say distance is equal to 7 meter. So this number tells us how much distance is. That how much is nothing but magnitude. So every physical quantity has a magnitude. Displacement also has a magnitude. If I write displacement, let's say 7 meter itself, this is a magnitude of the displacement. But distance has magnitude alone. Displacement has got magnitude as well as direction. Just now I have explained displacement has direction, and therefore remember the distance is a scalar quantity. Any physical quantity having only magnitude is called scalar quantity. I'll take up this discussion in the next video tutorial, but for this you please remember that, right, please remember that any physical quantity which has only magnitude is scalar, and a physical quantity which has magnitude and direction is vector. Right? So now tell me, which is vector? Displacement is a vector quantity. Now quickly I will explain you what is the solution for the problem which we have taken. Now on paper we should be very sure and familiar about the direction. And what will be the direction? North, east, south and west. Right? Okay. So this is north, east, west and south. A man travels a distance of 1.5 meters towards east. So let's take it goes 1.5 meter towards east. This is cancelled. So it is towards east, and then 2 meters towards south. So it is going he is going south. So that is 2 meter he is going south. The first he has gone to 1.5 meter towards east, and then east, yeah, and then towards south, and then after that he has gone 4.5 meter towards again east. So he is moving front. So final diagram will be here. You have to find out the distance covered and displacement. Now you are very familiar what is distance covered? Actual distance covered. I repeat, distance covered is the actual path covered. And what is the actual path covered? 1.5 meters plus 2 meters plus 4.5 meters. Altogether, whatever answer you get, that will be in terms of meter, and that is the distance covered. Okay, I'm not going to do that calculation. This is left for you. I explain you that what is distance traveled and total displacement. Please write your answer in the comment box below this video if you could understand this problem. Okay, now going for displacement. And what is the displacement? This is the initial position A. Let's say this is initial final position B. So what is the shortest distance between initial position and the final position? That is AB. So that is shown by dotted line, and that itself is displacement. And how will you calculate displacement? You have to complete the triangle here, right angle triangle here. And how will you do that? Extend these lines, okay, and join here. So you will get the measurement here. This is equal to 1.5 meter and this is 4.5 meter. So this will be equal to this, that is 2 meter, and hence 4.5 meter and 1 meter amounts to 5 and 6 meter. So this complete, if you call this as C, BC is 6 meter, CA is 2 meter. Find out by using Pythagoras Theorem the length of AB, which is equal to displacement. Please write in the comment box the answer. Okay, we'll take up some other concept in the next video. Thank you very much.